So, good morning, sir. Today our topic is applications of the linear algebraic method for control systems design and good YouTuber Google Drive. Google Drive. So, introduction to control systems design. Control system design is a critical aspect of engineering that involves managing the behavior of dynamic systems. Linear algebra plays a vital role in analyzing and designing control systems. This presentation will explore various applications of linear algebra in control systems. In control systems. In control systems. Control systems. This presentation will explore various applications of linear algebra in control systems design. So, fundamentals of the linear algebra. Linear algebra provides tools for solving systems of linear equations which are fundamental in control theory. Concepts such as matrices, vectors, and eigenvalues are essential for modeling dynamic systems. So, understanding this fundamental is crucial for effective control system analysis. So, when algebra provides tools for solving systems of linear equations which are fundamental in control theory, concepts such as matrices, vectors, and eigenvalues are essential for modeling dynamic systems. Understanding these fundamentals is crucial for effective control systems analysis. So, state space representation transforms a system's differential equations into a set of linear algebraic equations. This approach allows for a compact and efficient analysis of multi-input and multi-output systems. Linear algebra techniques facilitate the manipulation of state space models of for design purposes. State space represented transforms systems, differential equations, and the set of linear algebraic equations. This approach allows for a compact and effective fictional analysis of all the inputs and systems. Linear algebra techniques facilitate the manipulation of state models for design purposes. So, controlled bit and observability. A control bit design means the systems can be driven to any desired state using appropriate inputs. So, observability assesses whether the internal states of systems can be inferred from its outputs measurements. Linear algebra provides a necessary and a sufficient for controllability and observability using rank conditions. So, controllability determines whether the systems can be driven to a desired state using appropriate inputs. Observability assesses whether the instance states of the systems can be inferred from its outputs measurements. So, linear algebra provides necessary and sufficient conditions for controllable and observability using rank conditions. Stability analysis. Stability of a control system can be analyzed using eigenvalues derived from the system state matrix. Linear algebra technique help determine the location of eigenvalues in the complex plane. Rutherford's criterion, the Rutherford criterion and Eponov's stability theorem are often employed in conjunction with the linear algebra. So the stability of control systems can be analyzed using eigenvalues derived from the system's matrix. So linear algebra techniques helps to determine the location of eigenvalues in the complex plane. The Rutherford criterion and Eponov's stability theorems are often employed in conjunction. Linear algebra feedback control design aims to improve system stability and performance by using feedback mechanisms. Linear algebra methods such as pole placement allow for design of state feedback controllers. So feedback control design aims to improve system stability and performance by using feedback mechanisms. So linear algebra methods such as for sorry sir, 1 minute. Health is not good, sir. So sorry. So feedback control design aims to improve system stability and performance by using feedback mechanisms. In an algebra methods such as pole placement allow for the design of state feedback controllers. The use of state observers can also be integrated to enhance system performance. So feedback control design aims to improve system stability and performance by using feedback mechanisms. So linear algebra methods such as place replacement, so there are state feedback controllers. The use of state observers can also be integrated to enhance system performance. So feedback control design aims to improve system stability and performance by using feedback mechanisms. So linear algebra methods such as pole placement allow for the design of the state feedback controllers. So the use of the state observers can also be integrated into the system performance. So feedback control design aims to improve the system stability and the performance by using the sources statements. The linear algebra methods such as pole placement feedback controllers. The use of state observers can also be integrated to enhance system performance. So, optimal control strategies. So, linear quadratic regular LQR design is a popular optimal control strategy that utilizes the linear algebra. The objective of LOR is to minimize the cost function, balancing state error, LQR, and error candle effect. So, objective of LQR is to minimize the cost function, balancing state error and control effect. We know LQR means linear quadratic regulator. So, so this is one of the strategies we are widely used. So linear algebra facilitates the derivation of the optimal account. So they are all through a matrix polynomial a robust control design. Robust control addresses the uncertainties in system dynamics using linear algebra approaches. Techniques such as infinity control utilizes the linear matrix inequality to calculate the performance and pay solution. So this ensures that the control system remains the stable performance well like the same system dynamics. So there are some of numerical methods in control design. Numerical methods leverage linear algebra to solve complex controls design problems that cannot be solved analytically. So techniques such as singular value decomposition (SVD) and QR decomposition improve the computational efficiency. The QR means the quadratic regulator. So these methods are vital for simulations and real-time control systems implementations. So these are widely used techniques and numerical methods are used very widely in our control design. So this plays very crucial roles. Okay. So numerical methods leverage sorry. So the numerical methods in control design. So numerical methods leverage linear my bird flu వచ్చినట్టు ఉంది. So that's what the wash is not going to. So numerical methods leverage linear algebra to solve complex control design problems that cannot be solved analytically. So techniques such as singular value decomposition and QR decomposition improve computational efficiency. These methods are vital for simulations and real-time control system implementations. So conclusion and future directions. Linear algebra remains an indispensable tool in control system design, influencing various applications and methodologies. Ongoing research will continue to enhance its applications in advanced control strategies and systems. So, as technology evolves, the integration of linear algebra with modern computational tools will drive future innovations in control systems. So this algebras are used in various social media platforms like YouTube and Google Drive. So these are plays a very vital role. Okay. So there are so many methods to access this type of algebras and to control this all system with some numerical methods or some tools will be the real QR like that. So yeah, it will be like SVR, SVD, singular value decomposition. So yeah, so linear algebra remains an indispensable tool indispensable tool in control system design. So it will be affects the design also, influencing various applications and methodologies. So ongoing research will continue to enhance its applications in advanced control strategies and systems. So it all affects the all affects the methodologies. So yeah. So as technology evolves, as technology evolves, the integration of linear algebra with computational tools will drive future innovations in control systems. So thank you for giving this wonderful opportunity. Sir, my name is Vishnuvardhan, Aero B section, 8th sem, 4th year. So thank you for this wonderful opportunity. Thank you, sir.